Now, Kubernetes is constantly evolving and receiving updates almost every single day. And if you're an engineer working on Kubernetes, you probably have to keep your clusters up to date quite regularly. Now, some time back, I've released a full series on Hashicorp Vault, where we've taken a look at how to get a vault up and running, the basics, how to get TLS communication between Vault and all its integrations, and how to create a basic secret in Vault and automatically injecting it into new pods, as well as dynamically creating secrets in something like a Postgres database, automatically expiring and rotating those secrets inside of pods that require a database connection to Postgres. That series covers all the basic information on Vault. So if you're new to Vault, check out the description link down below. So today we'll be taking a look at a Hashicorp Vault guide for a newer version of Kubernetes, which is Kubernetes 1.21. Now, it's important to note that Vault is integrated with Kubernetes using Kubernetes admission controllers. So it's important to keep Vault up to date as you keep your cluster up to date as well. So let's go ahead and deploy a Kubernetes 1.21 cluster and take a look at the latest version of Vault. We've got a lot to cover in this video, so without further ado, let's go. Now, if you take a look at my GitHub repo, I have a Hashicorp Vault folder, and in that folder I have a README, and that is the old guide to Hashicorp Vault for running Vault specifically on Kubernetes 1.17. That's a very important series as we cover the fundamentals of how Vault works, all the internals, TLS communication, as well as secret injection. In this video, I've added a new folder called Vault 2022, where we'll be taking a look at the latest version of Vault, as well as a newer supported version of Kubernetes 1.21. So if we go in the Vault 2022 folder, there's a README, and this is the updated Vault guide, where we'll take a look at spinning up a cluster, installing all the dependencies, running a console for backend storage, as well as TLS communication. We'll go ahead and deploy and initialize the Vault, and take a look at basic secret injection. So be sure to check out the link down below to the source code so you can follow along. Now, the first step is getting a Kubernetes cluster up and running, and the highest version we can go is Kubernetes 1.21. That is because Vault uses Kubernetes admission controllers and a specific version of the admission controller API, which is only supported up to Kubernetes 1.21. For cluster versions 1.22 and up, we'll have to wait for a newer version of Vault. So in this demo, I'm going to use Kind. You could use Minikube as well. Kind is a very lightweight project for deploying Kubernetes clusters in lightweight Linux containers. So we can use these lightweight clusters for testing. So the first thing I'm going to do is change directory to the Hashicorp Vault 2022 folder. And in this folder, if you take a look at the left here, I have a kind.yaml. And the kind.yaml tells Kind what my cluster should look like. So I'm going to run one master node and 3 workers. So to spin up that cluster, I'm going to say kind create cluster. I'm going to call it Vault, and I'm going to run the Kubernetes 1.21.1 image and pass in my kind config. If I copy paste this to the terminal, we see it's going to go ahead and create our Kubernetes cluster. So it's creating our cluster called Vault, preparing our nodes, and after about a minute or so, we can see our cluster has now been created, and we can do kubectl get nodes to view our Kubernetes cluster nodes. So if I run that, you can see we have a master with 3 worker nodes. Next up, I'm going to run a lightweight Alpine Linux container where I can deploy all my dependencies. I'm going to install kubectl as well as Helm, and I'm going to use that to install Vault. So to do that, I'm going to say docker run -it for interactive --rm to remove the container when I'm done, and then I'm going to run it on net host so that my container can access the kind cluster. Then I'm also going to mount in my .kube folder, because that's where my kube config lives. That is so we can communicate with our kind cluster from within the container. I'm going to mount that folder in, and then I'm also going to mount in my working directory. That's the directory that we're in at the moment, which is the Vault 2022 folder, and I'm going to set that as my working directory with the -w flag, and then I'm going to say I want to run Alpine with a shell terminal. So I copy paste that into the terminal, and we're now inside of a Alpine container. If I do ls-l, we can see I have all the files on the left here. Now to interact with our cluster, we're going to need kubectl, and that's very easy to install using curl. So I'm going to go ahead and say apk add curl, Then I'm going to download the latest version of kubectl. I'm going to give it chmod permissions to execute and move it to user local bin. So I copy these commands, paste it to the terminal, and that'll go ahead and install kubectl. Now when that's done, I can say kubectl get nodes, and we can see we can now access our Vault cluster from within this Alpine container. And the other thing I'm going to install is Helm. So I'm going to say curl, I'm going to download Helm 3.7.2. I'm going to unzip it, and then I'm going to move the binary into user local bin. So I'm going to copy paste this to the terminal, and that'll go ahead and install the Helm CLI. And when that is done, I can say Helm, and we can see we have Helm installed. Now the reason I'm running a lightweight Alpine container is so I can go ahead and install Helm. And the reason we need Helm is because the Vault community maintains a Helm chart for Vault as well as its storage backend. Now in this demo, I'll be using Helm to grab the latest Helm charts of Vault, and more importantly, look at the Kubernetes YAML manifests and understand all the components. Now in order to access all the Helm charts, we're going to use Helm to add a repo called Hashicorp. So we say Helm repo add Hashicorp with the link to that repo. So I'm going to go ahead and copy paste that to the terminal, and that will add Hashicorp to our repositories. Now Vault has several different types of storage backends, because remember, Vault has to store its secrets somewhere. It can't keep it in memory. So we can either store it onto disk using a Kubernetes volume, which is something we did in our previous guide. But the default backend for Vault is Hashicorp console. So in this demo, we're going to spin up a single console server and use that for demo purposes. Let me know down in the comments down below if you would like to see a Hashicorp console guide. Now to deploy console, we're going to use the console Helm chart. So the first thing we want to do is find the latest version that we'd like to use. So I'm going to say Helm search repo Hashicorp/console and print out the versions. So if I run that, we can see that the latest chart version is 0.3. Now what I'm going to do is I'm going to use Helm to grab the Kubernetes YAML from that repo. So instead of just installing it directly, I'm going to grab the YAML so that we can take a closer look. So I'm going to say mkdir manifests to create a manifest folder on the left here. And then inside that, I'm going to download all the YAML. So I'm going to say Helm template console, pass in the name of the repo, the Hashicorp console. And I'm going to say I want to use a namespace called Vault, and I want to grab version 0.39, and I'm also going to pass in console values, which we'll take a look at in a second. And then I'm going to pipe that and print it out to my manifest folder in a console.yaml file. So I'm going to go ahead and copy paste this to the terminal, and that'll generate a manifest for console. This is the full YAML used to deploy our single console server. Now the way we pass our parameters into Helm is by using a values file. You can see I said -f console-values.yaml. And if we take a look at that YAML file, it is the most basic values file for a single server of console. So we say we want a console client, we say we want one server, and that's pretty much it. Now to get this console service up and running, what I'm going to do is say kubectl create namespace. I'm going to create a Vault namespace where I'm going to keep everything such as Vault and console. And then we say kubectl in the Vault namespace apply the console.yaml. So I'm going to go ahead and apply that, and that will go ahead and create some service accounts, a config map, some role and role bindings. It'll create Kubernetes services as well as a daemon set for our console. It'll create a stateful set for the console service as well as a test client pod. If we do kubectl get pods, we can see that we have our console server up and running. There's one server, and if we give it some time, we can see all the pods are now ready. Now feel free to take a look at the console.yaml to see how the Helm chart generates. So now we have our console storage up and running. The next step is to get TLS certificates so that Vault communication can be fully encrypted end to end. And in this guide, we're going to be using our own self-generated TLS certificates. And if we take a look at the README guide, we have steps generated in the TLS folder. I have a README in here called SSL generate self-signed. And if we go to this file, we can see this is how we're going to be generating our certificate. And it's very easy. So to generate the certificate, certificates, what I'm going to do is I'm going to create a new terminal. I'm going to change directory to the Hashicorp Vault 2022 TLS folder, because in this TLS folder, I have two configuration files, one for the CA and one for the certificate signing request. And we're going to be using the Cloudflare tool to generate these certificates, which is very simple. So I'm going to run a lightweight Debian container where I can install these utilities. I'm going to mount in my local folder, which is the TLS folder we are in, and I'm going to run Debian with a simple bash terminal. So I go ahead and copy paste this to the terminal, and now we're inside of a Debian container, and we can see we have our configuration files over here. The first thing I'm going to do is say apt-get update, install curl, and I'm going to use curl to download two binaries. The one is the Cloudflare SSL binary for generating self-signed certificates, and the other one is for dealing with JSON. So I'm going to go ahead and copy this to the terminal, and that'll go ahead and download those two binaries that we need. Now, if we take a look at our config files, we have one for the CA, which says the default expiry. So here we can set an expiry for our certificate. And then we have a CA certificate signing request file where we can add some additional properties to our generated certificates. Now, to generate a certificate, it's very simple. What I'm going to do is say cf_ssl gencert. I'm going to pass my CA certificate signing request JSON in, and I'm going to pipe the output to the Cloudflare SSL JSON utility and output everything under the temp directory. So I'm going to copy paste that to the terminal. That'll generate a new CA certificate, and then I'm going to generate the certificates in the temp folder. So I'm going to say Cloudflare SSL gencert, pass in the CA I just generated, pass in the CA key, pass in our CA configuration file, and this is the important part. This is all the fully qualified domain names that we want the certificate to be valid for. You can fully customize these host names to make the certificate valid for the URL you need. I'm going to pass in the default profile, and then I pass in my certificate signing request, pipe the output to Cloudflare SSL JSON, and put all the output under /temp vault. So I copy paste that to the terminal, and that will generate my certificates. Now, to view my certificates, I can say ls-l in the temp directory. There's everything over there. I have my CA certificates as well as my Vault certificates. Now, to grab the files, I'm simply going to go ahead and move them from the temp directory to my local working directory. Now we can see them all on the left hand side here. Remember not to commit your sensitive values to Git. And now that we've created our TLS certificates, we're going to have to go ahead and create some Kubernetes secrets for those certificates. So we need to create two secrets. One is for the CA and the other one is for the TLS certificates. So we say kubectl in the Vault namespace create secret, and here you can see I'm going to create a secret of type TLS called TLS-CA, pass in the CA PEM and the CA key. Go ahead and paste that to the terminal. That'll create the TLS-CA secret, and then I'm going to do the same thing for the TLS certificate. So I go ahead and copy paste that to the terminal. That'll create the TLS server secret. So now that we have our console storage backend as well as our TLS certificates, let's go ahead and use the same method to download the Vault Helm chart and take a look at the YAML files. Now, to generate the Kubernetes manifest for Vault, I want to hop back into my Alpine Linux container, and I'm going to say helm search repo hashicorp/vault and print out the versions. Now, if we run that, we can see that the latest version is 0.19.0. Now, before we grab that Helm chart, let's take a look at my values file to customize the Vault. So similarly to the console.values, I have a vault.values file. And if we take a look at this, this is the minimal YAML that you'll need to get a Vault server up and running with basic secret injection. Here I say TLS disable is false, so we want TLS on. I say I want injector to be enabled so we can inject secrets, and the image to use for the secret injector. I can specify resource request and limits, and notice that I've drastically reduced this from the default so that I can fit everything into my kind cluster. And for the server, I can say which Docker image and tag I want to use. Then we can also specify a readiness and a liveliness probe, and this is the important part. We want to specify environment variables to tell Vault where our TLS certificates live. So there's an environment variable here to specify where the CA certificate is, and we're going to be mounting that certificate into the pod. Then we also specify extra volumes for our CA as well as our TLS certificates for the server. So those are the secrets that we're going to be creating for our TLS certificates that we created earlier. Then we say we want standalone to be false. We want HA enabled with 3 replicas. And this is where we can fully customize the configuration files. So I say I want the UI to be on so that we can take a look at the vault. I want TLS to not be disabled. I specify my address, the TLS certificate, cert and key file locations, the minimum TLS version, as well as the storage backend. And I tell it here that I want to use consul, and this is the address of our consul server. And then I also tell Helm that I want the UI service to be deployed and the port to expose it on. So this values file gives you the capability to fully customize Vault as per your needs. Now to grab the Vault YAML files, I'm going to say Helm template Vault, pointed to the Hashicorp Vault repo. I'm going to use the namespace Vault. I'm going to use version 0.19.0. I'm going to pass in my values file that we've taken a look at, and I'm going to print all the output to a manifests folder on the left here into a file called vault.yaml. So I'm going to copy this to the terminal, and that'll generate our vault.yaml on the left. Now, if you take a look at this YAML, this has got all the components needed to run Vault. Now, as I mentioned earlier, you can use Helm install command to install this directly to your cluster and use Helm upgrade to upgrade it in the future. In this demo, we're going to use Helm template to take a look at the YAML file so we understand it a little bit better. And we're purely doing this for learning purposes. Now you can see here it has a pod disruption budget. It has service accounts for the Vault agent, a service account for Vault, a config map generating the config that we showed earlier. It has a bunch of cluster roles and role bindings. Here you can see it has these injector service, so a bunch of Kubernetes services here. It has a service for the active Vault pod. It has another service for the standby pod, a service for the Vault cluster, a service for the Vault UI. It has a deployment for the Vault injector, and you can see the full deployment YAML here, as well as a bunch of environment variables to tell the injector where the Vault lives. So you can see that all down here. And then over here it has a stateful set with 3 replicas, and this is the Vault itself. If you scroll down, you can see all the volumes it's going to create for the TLS certificates. It's running Vault 1.9.0, and you can see the entry point for how it bootstraps everything up and runs its own entry point here. And if we scroll down, we can see some more secret references for the TLS certificates for mounting it to a volume. It has a readiness and a liveliness probe, and this is important to understand. When the Vault pods spin up for the first time, the Vault is going to be sealed, and the liveliness probes will double check and make sure the Vault is not sealed. So the pods will continuously restart until they are unsealed. And then we have some mutating webhook configurations for our Vault injector. And finally, a test pod to test the Vault server. And now that we've taken a look at all the YAML, we can go ahead and deploy that by saying kubectl in the Vault namespace apply -f and apply the Vault YAML file. We go ahead and run that, and we can see it's created all the components we described in the YAML file. We say kubectl in the Vault namespace get pods. We can see all the pods are now coming up. We have Vault 0, 1, and 2, as well as the injector, as well as the test pod to make sure everything is working. Now it's important to notice that these 3 Vault nodes will remain in a non-ready state until the Vault is unsealed, and they'll automatically restart until the unseal process is completed. Now there are solutions out there for automatically unsealing the Vault. In this demo, what we're going to do is get a shell terminal to each of the Vault pods and unseal them. So the first thing we need to do is get a terminal into one of the Vault pods. So I'm going to say kubectl in the Vault namespace, exec into Vault 0 and get a shell terminal. And when we do that, we're now in the Vault. We're going to say Vault operator init. Going to go ahead and paste that. And it's important that we grab all the unseal keys as well as the root token. So I'm going to create a new window where I'm just going to paste that in. And we're going to go ahead and unseal the Vault. So we need to do this 3 times per Vault instance. So I'm going to say vault operator unseal. I'm going to give it a key. I'm going to run vault operator unseal again, give it another key, and I'm going to run vault operator unseal again. And notice that the liveliness probe has killed the pod. So we're going to have to repeat this process until we can unseal the vault. So to do this again, I'm going to say kubectl exec, go into the pod. I'm going to run vault operator unseal because we've already initialized it. Pass in a key, type unseal again, pass in another key, vault unseal again, pass in another key. So now I can type vault status and we can see it's initialized is set to true and sealed is set to false. So we've unsealed this specific instance. So now we can exit out of this container. We can say vault get pods and we can see now vault 0 is ready. Now what you will see is that the other pods will still be restarting in a loop because they're constantly being killed because they are still sealed. So if we go into vault 1 and we say vault status, we can see that this vault is still sealed. So we have to unseal every pod. So we're going to say vault operator unseal, and we're going to repeat this process on this pod as well. So I've unsealed it 3 times. We can now see sealed is false. Then I'm going to exit and I'm going to repeat this process on vault 2. Now I've unsealed that vault 3 times and we can see sealed is now equals to false. So if I exit out and we say kubectl get pods, we'll now see that all 3 vaults are ready, running, and they'll stop restarting because they're all unsealed. To confirm this, we can run vault status on every pod. So when we run that, we can see sealed is false. We can run that same command on vault 1. We can see it's sealed is false. And I can run that command on vault 2 as well. And we can see sealed is false. So now our vault is completely unsealed and ready to be used. Now the vault sealing process is specifically designed so that one person cannot unseal the vault. So you're meant to distribute these keys among different people and use different people in your organization to unseal the vault. Now to access the Vault UI, we need to port forward to the Vault UI service. So in another terminal, I'm going to say kubectl in the Vault namespace get service, and we can see that we have a Vault UI service over here exposing port 8200. So to port forward to that, I say kubectl port forward to that Vault UI service, and I'm going to forward 443 to 8200. So I'm going to select that, copy paste it to the terminal, and that'll port forward in this window so that I can access the UI. Now if I access localhost on 443, I can go ahead and access the Vault UI, and it's important that we grab the initial root token so we can log into the user interface. So over here I'm going to say my method is token, pass in that, and we can access the secret engine and everything to do with Vault. So the UI allows us to view our different secret engines. We can look at the different secrets stored in each one. We can set up access as well as policies. So the secret engine allows us to store different types of secrets. We can have like key value pairs, certificates and SSH keys, cloud-based secrets, as well as infrastructure-based secrets. Now to be able to automatically inject secrets from the vault into our Kubernetes pods, we need to enable the Kubernetes authentication. This is so that our Kubernetes injector can access the vault. So to do that, what we're going to do is go into one of our vault pods, get a terminal, we're going to say vault login, and for that we're going to need the initial root token. So we go ahead and paste that. Now we're logged into the vault, and then what we're going to need to do is say vault auth enable Kubernetes. So we're going to go ahead and enable that authentication mechanism, and then we need to write an auth config. So we're going to say vault write auth /Kubernetes /config. We're going to pass in the service account details for Kubernetes because our Kubernetes injector needs to be able to access the vault, and it's running as a Kubernetes service account. So when a pod runs as a service account, you'll see that it will have a service account token in var run secrets kubernetes.io /service account. So there's a token in there. So we're going to pass it that token from the pod. We're also going to pass in the Kubernetes host. This is where the API server address is, as well as the CA certificate. So we're going to go ahead and run this command, paste it to the terminal, and that will create the auth file for the vault. So now if we open up our Vault UI and go to access, we can see there's a new authentication method for Kubernetes. So now that we have Vault up and running, let's go ahead and see what it takes to inject secrets into pods using the Vault injector. Now to do that, it's very simple. I have an example apps folder with a basic secret injection guide over here. There's a README you can access over here. Now, in order for us to set up basic secret injection, we need to set up a policy for our application. So what I'm going to do is go into one of the Vault pods, and what I'm going to do is set up a new authentication policy. I'm going to say Vault write auth Kubernetes, and I'm going to give it a role called basic secret role. And in here, I'm going to pass in the name of a Kubernetes service account that is allowed to access secrets. So here I'm going to say there's a new service account called basic secret, and that service account is bound to a namespace called example application. And we're going to go ahead and set up that application in a moment. And then I give my policy a name called basic secret policy, and I give it a time to live, so you can make this policy expire over a given time as well. So I go ahead and copy paste that. That will set up our new role. That new role can be seen if we go to the Vault UI under access auth methods Kubernetes. We'll see the role here called basic secret role. If we click into that, this binds a specific service account to this role. So when we deploy our pod, we'll create a service account for that pod, which will be allowed to get secrets. So now we've mapped our service account used by an example pod to a policy. Now let's go ahead and create the policy to map our service account to a bunch of secrets. So to do that, again, I'm inside of the Vault pod. I say cat and I write an application policy in HCL configuration format. So here I'm basically saying that our service account can access any secret under the folder called secret/basic secret/star. This is the folder structure we'll create in the Vault, and will allow our application to only view secrets under this folder structure, and it will be able to read. So I'm going to create this policy file, and then I'm going to apply it by saying Vault policy write the basic secret policy, and pass in the config file. So that means our service account, which will be bound to our example application, will be able to access specific secrets under a specific folder in the Vault. So to see that in the UI, we can go to policies, and we can see we have a basic secret policy, which tells us exactly what path we're allowed to access and the type of access. So let's go ahead and create some secrets. So the way to do that is, again, go into one of the Vault pods and say Vault secrets enable, and we're going to enable key value pair secrets in the /secrets folder. So we go ahead and do that. That will give us a key value store under /secret. And then we go ahead and define a secret by saying Vault kv put. We put a secret into the specific path, and we're going to provide a secret just called a username and a password. So we're going to provide a DB user with an example password. So I go ahead and copy paste that in the terminal, and that's created a new secret under secret basic secret called hello world. We can view that secret in the Vault dashboard under secrets. We can see there's the path called secret, and here's the folder called basic secret. This is the folder that our service account is mapped to, and it'll be allowed to read any secret in this folder only. And if I click that, we can see our hello world secret with our password and username. So these are the basic steps that operations will follow to define secrets as well as policies on who's allowed to access those secrets. Instead of passing these secrets directly to development teams, we can set up the secrets in Vault, create policies, create service accounts, and pass those service accounts to development teams to consume. So as a developer that wants to deploy applications, I would need a secret to use. Now, I don't actually need physical access to that secret. All I need is a service account to use in my pod. So in my folder here, you can see I have an example apps folder, and in that folder, I have a basic secret folder with a deployment.yaml. So as a developer, I would write my deployment.yaml with my application that I want to deploy, and more importantly, I would create a service account called basic secret. This is the service account I would give to my operations team to set up the policies in Vault. And then under my deployment, I just say I want to use that service account, and then I can go ahead and run my application. So to consume a secret, all I need to do is specify an annotation on my deployment to say Vault Hashicorp.com agent secret injection and the secret that I want to inject. So you can see here I say secret/basic secret/hello world. This is the secret I am interested in, and you can see I specify a template with the format I want to generate the secret in. So I can generate it in a specific format that my application can understand. And this is the role to use. So the operators of the vault just needs to specify a role that you can use as well as a service account. And as a developer, I don't need physical access to the vault at all. So I'm going to go ahead and create an example app namespace, and then I'm going to go ahead and deploy my YAML file by saying kubectl apply in the example app namespace, apply my new deployment. That will go ahead and create my deployment as well as my service account. Now, if I do kubectl get pods in the example namespace, I can see I have my application running. And to double check if my pod now has the secret injected, I can say kubectl in the example app namespace exec. So I'm going to copy that to the terminal, and then followed by the pod name, and followed by sh-c. I'm going to run a command inside the pod and just say cat, and then cat the contents of the secret to see if it exists. So I go ahead and run that, and you can see it's injected the contents of the secret into my pod. So hopefully this video gives you a good rundown of deploying the latest version of Vault onto a newer version of Kubernetes. Remember to check out the Vault guide and let me know down in the comments below what sort of videos you'd like to see in the future. And remember to like and subscribe and hit the bell. And if you want to support the channel even further, be sure to check out the Patreon link down below or become a YouTube member. And as always, thanks for watching, and until next time, peace.